Okay, we've already added and subtracted complex numbers. Tell me what's the... Okay, so what is the standard form for a complex number? Very good. A plus BI. And so when you add them, you just add the real parts and the imaginary parts. Everybody agree? And when you subtract them, then you just, do the same thing. All right, so let's talk about some division. Three over 5I. Oh, we didn't do multiplication. What's wrong with me? I've got my mind on Friday afternoon after school. Sorry. So first rule, when you multiply, you cannot, y'all, that's true about anything. You can't do any of the operations until you have simplified it. For instance, if I give you something like the square root of negative 4 times the square root of negative 16. You cannot multiply negative 4 times negative 16 and say, oh, that's the square root of positive 64. It's 8. You can't do that, okay? You have to pull the I out. You have to get that in the proper form. So this is, what is the square root of negative 4? 2I. Very good. Times, what's the square root of negative 16? Not negative 4I, just, there you go. Be careful about putting the negatives. You want to do that. A lot of kids will do that. That's a common mistake. When I say, what's the square root of negative 4, they'll say negative 2. And then if they get the I in there, they still want to put that negative sign on there. It's not. It's just 4I. And then what's 2I times 4I? And is I squared legal? No, he's not. What is I squared equal to? Negative 1. And so what's 8 times negative 1? Negative 8. All right, so we learned an easy way to remember those. Does anybody remember what it was? I1. Keep your negative stuff on the inside because we don't want to see it. Leave your positives on the outside. This is the square root of negative 1. This is I squared. This is I cubed. And this is I to the 4th. Okay? In this box, these right here are not acceptable. Any of these on the test, negative is under radicals, see, or I to any other power other than 1 are not acceptable. They'll be counted wrong. These are acceptable. Okay? All right. What if I said, what's 2 times 3 plus 4I? What are you going to do? Yeah, you're just going to distribute the 2 and tell me what you get. Can I simplify that any? No, that's my answer. All right, so what if I gave you 2 complex numbers, like 2 plus 3I times 4 minus 8I? Yeah, you're just going to FOIL it. You did this in Algebra 2, so it shouldn't be totally new to you. FOIL method says first times first with 2 times 4, 8. The outers give you a what? Negative 16I. The inners give you a what? Positive 12I. What's a positive 12I and a negative 16I? And then you have your last times your last. What's 3I times negative 8I? Very good. All legal? No. Cannot have an I squared, guys. I squared is what? Negative 1. So all that was going to do is do what to this guy? Change his sign. If this is a negative, I'm okay with you slashing that and making that a positive. Now, do I have any like terms to collect? Yes. What's 8 and 24? So 32 minus 4I. Yeah, you have to. It's always in the form of A plus BI, that standard form. So the real number comes first and the imaginary part comes second. Now, guys, listen to me. Your test on Thursday, the first thing I'm going to do is give you a piece of pink paper, which means you won't be using a calculator, okay? And then after you finish with that, and it's going to have addition, subtraction, multiplication, and division of complex numbers, okay? So you have to do them without a calculator. But then when you finish with that, I'll give you a white piece of paper. It will still have some of those problems on there, but you can use a calculator. I want you to know how to use a calculator, but you need to understand what the calculator's doing. Can I do this on a calculator? Yeah. So you need to know how to do that, okay? So if you get a calculator, 2 plus 3, 4 minus 8, all right, then you can put it in your calculator. So this is what it would look like. Here's where the I is, above the decimal point. So it would be 2 plus, oh, I need to put it in parentheses, sorry. 2 plus 3 I times, what was it? 4 minus 8 I? 4 minus 8 I. So what I would do in my worksheet is I would do it without a calculator first, and then I would put it in the calculator and check it in the calculator. Okay? Anybody got a question? There is a mode on your calculator, and it is this A plus BI. You can put it in that, so it'll give you the answer in that form. All right? Real numbers, imaginary numbers. All right? Let's try another one.
So long division of
Polynomial. Yeah. Going back a little way. Remember, it's kind of been dragging out because we've been, it's been the crazy. It's just been insane. All right. So let's try another one. You do this one. Is that what y'all got so far? And then last one, class, gives me plus 3I squared. I did want to show you one thing, because whenever I grade papers like this, I see one mistake that happens a lot, and that's when this is a plus sign. The kids don't want to, they just want to make it a minus sign, and then it gets lost somewhere. So what I would suggest you do, if you're going to do that, just cross the whole thing out and write minus 3. Don't just make that a negative and then cross out that I squared, because I've just seen a lot of kids make mistakes. So 8 minus 3 is 5 plus 14I. All right, anybody got a question? Okay, so what if I multiplied, hey, y'all remember when we multiplied things like this, x plus 7 times x minus 7? Are these special? Conjugates, okay? When you multiply conjugates, what happens? The middle disappears. The plus 7x and minus 7x cancel each other out. So you're left with square the first minus square the last. So you're left with the difference of two perfect squares, right? Do y'all remember that? Okay. So what happens if I multiply complex conjugates? Like, what if I multiplied 2 plus 3I times, what's his conjugate? 2 minus 3I. Okay? Do the inners and the outers still disappear? Yes, they do. Plus 6I, minus 6I. So can I still go square the first, 4, minus, square this last, and what do you get? What? 9I squared. Very good. Now what is that I squared going to do to it? He's going to change that negative 9 to a positive 9. And then what's 4 plus 9? 13. So when I multiply complex conjugates, what kind of number do I get for an answer? A real number. It gets rid of the imaginary part. You're not going to need it anymore. So let's do another one. What about this one? 4 minus 5i times 4 plus 5i. You do it. I don't know who that was. It sounded like
So
what?
with the eyes and the other side like that, is it always going to be square of the first plus the square of the coefficient?
And that's what we want to look at it like, okay? All right, so this is going to be 16 minus 25i squared, and then the I squared is just going to make it a plus, so it becomes 41, right? Now, so this is what Trey said. Well, is it always going to be square of the first plus square of the second number? It is. It is, guys. It's going to always be that way. So, how long should it take us to do one? Not too long. So let's do 2 plus 6i and 2 minus 6i. Now really all it is square of the first, what? 4 plus square this last number. If you're going to put a plus sign there, don't put the I on it. Okay? And what is 4 and 36? 40. Okay? So, y'all, this is going to come up later on. All right? It's going to come up later on, so you need to have it down pat. So I'm going to give you some more to practice on.
Plus 36, like minus.
Why? Because it's minus a 36i squared, and that I squared is going to always make that a plus.
Yeah.
Okay? All right, so I'm going to give you one, and I'm going to give you, how many seconds you think you should take to work it? 5, so I'll give you 10. Okay? I'll give you 10. If you think you can do it in 5, I'll give you 10. Are you ready? No, I do believe in you. So, 2 plus 7i times 2 minus 7i. All right, what did y'all get? Very good. 4 and 49 make 53. Okay, so now I'm going to do another one. This one's going to be more difficult. Not because I'm going to make the numbers harder, but because of what I'm going to do. Okay? 6 plus 3i times 6 minus 3i. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. 45? Very good. Why was it harder? Because I was counting, and so as soon as I started counting, what did your heart rate start doing? It went up? Yeah, and a lot of people just went, oh my gosh, oh my gosh. Like, I only have 8 seconds left. No, just because I count. Last period, oh my gosh, I started counting and they just all went, oh my gosh, stop counting, stop counting. Like, no, it's going to be okay. No, we don't want to make it crazy. All right, let's do another one. 3 over 5i. We're going to divide. Okay? Got a problem? Oh, why can't I have an I on the bottom? No. It's a radical. It's the square root of -1. Okay. Okay? It's the square root of -1. And you can't have a radical in the denominator. Okay? So what am I going to do to get rid of that radical down there? Multiply by I. Okay? Do it 5i? No, 5's not a problem. Nobody said you can't have 5 in the denominator, okay? We said you couldn't have I in the denominator. Now, do I have to do anything else? You have to multiply the top by I. Why am I multiplying the top by I?
Multiplying by 1.
That's right. Y'all listen to me. I asked my Algebra 2 kids that because they're working rational functions. And I said, why do you multiply the top by it? And they were like, that's the rule. And I go, but why? And they said, because that's the way they taught us to do it in the 6th grade. And I'm like, but why? Not one person knew why. Okay? But this morning, Parker said, because you got to make the one machine. That's the way they taught him, I guess. I don't know. And so he said, well, you make the one machine by putting it over itself. So, but that made that stick in his head that you're multiplying by 1. It's the only thing in the world that you can multiply by and not change its value. All right. So on the top, what's 3 times I? On the bottom. Yeah, that's 5I squared, which is negative 5. Oh, is this a problem? We got a negative on the bottom. It's not a problem. Hey, could I write this like this?
What if you did multiply it by like -1?
Negative 1?
Like if they multiply the whole problem by -1, would it be wrong?
Yeah.
We're not changing the value of the right.
Yes, you are. You mean having $1 million is the same thing as owing $1 million?
Okay, that makes sense. But okay, what if I multiplied it by 3 over 3?
Okay.
Then you'd have 9 over 15I, and you still got a problem. You just have to simplify. What if you, listen, y'all listen to this question. What if I multiplied, because I accidentally got a little stressed, lost my brain, and multiplied both sides, both the top and the bottom by 5I? Yeah, it's not that it's wrong. You're going to get 15I over negative 25, and then you're going to reduce them. Okay? So it's going to end up being the same thing. I want to know, can I write it like, oh, come on, little pen. I want to know, can I write it?
Negative 3I over 5.
Can I write it like that? Negative 3I over 5. Can I do this?
Yeah, it's on the denominator.
Okay. Could I do this?
Yeah.
That's perfectly fine.
Yeah.
Is that okay?
You don't do it on the bottom.
Just down to the bottom. I can do it anywhere, right? You can do it on the bottom or on the top or in the middle. Can I do it on the top and the bottom?
No, that makes it a positive.
Very good. All right. So, let's do one that's more difficult, okay? Uh-oh. Get off there, Ken. Yeah, that one. Did y'all get that one? All right. Let's do 2 over 3 minus I.
Ooh. Guess what we gotta multiply?
I got I in the denominator, guys, and you can't have it. Dallin, what are you going to multiply by? It's conjugate. Remember, we talked about how if you multiply by its conjugate, then you get a real number. What's the conjugate of 3 minus I? And whatever you do to the bottom. Because they said so in the 6th grade, right? All right. And what do you get on the top? And on the bottom, we learned how to do this in less than 10 seconds. So 9 plus 1. Very good. It's minus an I squared, which becomes a plus 1. 9 plus 1 is 10. Good answer? Why? Very good. So what can I do? All right. So you took a 2 out of everybody, right? 2 out of here and got 5. 2 out of here and got 3. 2 out of here and got 1. So 3 plus I over 5. Good answer. All right. Will my calculator do that for me? Oh, yes, he will. Now, wait a minute. Do you know how the calculator is going to write it? 3 over 5 plus 1 over 5 times I. Okay? He's going to make it he's going to write it in A plus BI form. Okay? Now listen to me. I don't know why they do it sometimes and they don't do it sometimes, but last period every single calculator did it. And I don't know how to fix it unless it's the mode that you're in. So,
A plus BI.
You want us to do that?
yeah, I want you to do it in your calculator. 2 over 3 minus I.
Like, say you give us most of the problems.
Oh, I see what you're saying.
Yeah.
2 divided by, just a minute, 3 minus I. Okay, so first of all, look what form it puts it in. And then, I'm not taking decimals, guys. So I want you to go math, fraction, enter. And I want you to be really careful right here, because this is 3/5 plus 1/5 times I. It is not 3/5 plus 1 over 5I. Do you understand? If you put that I on that bottom, I'm going to mark it wrong.
It's not letting me do it.
It is wrong, because it's not supposed to be down there. Did you switch the mode, Trey? Is that what you did?
I did it without without the alpha button, you know? Just 2 divided by times 3 minus.
Without the alpha button.
Instead of just doing 2 over.
Oh, writing it as a fraction? Yeah, if you put it in as a fraction,
Fraction it won't work.
yeah, he's going to leave it as a fraction. Okay, Brent?
Okay, so say you give us like a list of problems, right? And it's like, hey, solve this with calculator. Would you accept 3 over 5 plus 1 over 5I, or do you want us to?
I'm going to leave mine like this, okay? What I want you to realize is that if this were on the SAT, ACT, a multiple choice question on my test, because it's pulling from a test bank, then it's going to look like this. Okay? So you have to be able to recognize that's the same.
Divided.
All right.
3 minus I.
Yeah, I have it.
No, you can't use the alpha button. Making a fraction like that's not going to work. You gotta do it like that. And it puts in the decimal, and you gotta do
The math.
math, fraction.
Okay, you have 2 minutes. Let's go. Hurry up. 2 minutes. No. By hand. By hand.
See, like started.
It's never too late.
That one's hard. That one's hard. Oh, no, it's not. My calculator is only wrong answer. No, it didn't. No, it didn't. No, no. It wasn't hard. Do we need to separate it in our room answer?
I'll take it either way. Okay, so here's what I want to know. I want to know if anybody used the rule up here. I hope so. Alright, square the first, 16. Keep the sign, plus. Twice their product. If their product's 12I, what's twice that? Plus square the last, 9I squared. What is that? minus 9. What is 16 minus 9? 7 plus 24i over, on the bottom, 16 plus 9 is 25. It is 7. It's a Pythagorean triple. 7, 24, 25 is. They are the numbers for Pythagorean triples. Okay. All right. Anybody got a question? So let me just show you a couple of things and let's talk about them. If I have 2 plus 3i over 2, can I cancel the 2's out? Very good. If I have 4 plus 6i over 3, oh, sorry, plus 6i over 3, can I reduce the 6 and the 3? No. Alright, you can do that. If you wrote it like Trey was talking, if you separate it, 4/3 plus, what's 6 over 3? Okay, you can write it that way.
You want us to do that?
Nope, y'all, I'm okay with this. It doesn't bother me at all, okay? I'm okay with that. Alright, anybody got a question? Do we need to work any more? Everybody okay? Alright, so I'm going to give you your worksheet. When's it going to be due? Thursday. You can have it done by Monday, but you don't have to. I'm sure y'all won't. But